Hi everyone. Today I will discuss about limit function as an introduction to the differentiation. Before we study about differentiation, we need to understand about a function that help us to find the value in the forbidden area. So let's start with the definition of a limit function. So what is limit function? For example, I have a function of fx equals to x squared minus 1 over x minus 1. So we can draw this function by making a table and then put some of the coordinates, the pairs of x and y, and we plot it like this. So if you plot, you will have a straight line. But if you notice, when we try to put x value equals to 1 to the equation, so we have f1 is equals to 1 squared minus 1 over 1 minus 1. And this equals to 0 over 0. So this is undefined. So if you see in the graph, when x equals to 1, there is no value of fx because the result of the function when x equals to 1 is 0 over 0, or this is an undefined answer. So this is a forbidden region that the function cannot find the value for x equals to 1. So what's wrong with this equation? Is the function wrong? Now, to find the approximation of the value when x equals to 1 from the function, so we have to see any values that approach close to x equals to 1. So let's try some values from 0.5. We put into the fx and we have 1.5. If I move closer to 1, so I try 0.9 and I have 1.9. I move closer again, so 0.99, it leads us to 1.99. As I move closer and closer to 1, so 0.99999, so the value is 1.99999. And if you see the trend, the value when x is approached to 1, the value of the fx is approaching to a number 2. So for this case, since we are looking from the number that close to 1, so we can use a limit function. So we say limit for x approach to 1 from the left side. Yeah, that's the meaning of the negative sign as the index of the number 1 there. So limit function when x approaches to 1 of x squared minus 1 over x minus 1 is approaching 2. So the conclusion from here, we can say the function gets close to 2 if we approach the number x equals to 1 from the left side, from a value that's smaller than 1, but it's very close to 1. Now let's see again. How if now we approach x equals to 1 from the right side? So we find the value of x close to x equals to 1, but it's a bit more than x equals to 1. So we try 1.5 the value is 2.5. As I move closer to 1, so I move backward to 1.1, it is equals to 2.1. And I move closer again, 1.00001, and it close to 2. So from here, I can say that for the limit function of x approach to 1 from the right side, yeah, we have the index of positive there. That means we see it from the right side, from the value that greater than 1 of x squared minus 1 over x minus 1 is approach to 2 as well. So from these two approximation, we know that if we try to find the value around x equals to 1, the function fx is getting close to 2. So from here, we try to modify the function. We factorize x squared minus 1 into x plus 1 and x minus 1, and then we can cancel x minus 1. So we simplify, it's only x plus 1. So the result of the limit function is equals to 2 by replacing the value x to the modified function. So from here, we can say that for limit of the function from the left side is equals to 2, from the right side is equals to 2 as well. So we can conclude that the limit function for x approach to 1 from the function fx is equals to 2. So this is a limit function. So we use the limit function to find a region that undefined. Yeah, if we have a normal function and there is no problem when we substitute the value of x to the function, there is no problem, so we no need to use the limit function. But we use the limit function to see the approximation value around that undefined region. Like this case, the function will be undefined when x equals to 1. So we see from the value around 1, and we find that the value is approach to 2. So we can say the limit function as x approach to 1 is equals to 2. Now from this limit function, so we can check whether the graph of an fx will be a continuous graph or it's a discontinuous graph. So continuous graph means there is no blank spot on the graph. So we have to satisfy if graph fx is continuous at a point A. So point A is a point on the graph that we want to check whether it is continuous or not. If we go back to the first slide here, this is not a continuous graph because when x equals to 1, there is no value. The value is equals to 0 over 0. So there is no value on the graph. So we say that this function is discontinuous, not continuous function. So to check whether the graph is a continuous graph or not, so we have to check. We go back to the slides. Yeah, this one still. I'm forwarding. Yeah. Okay, they are still here. Please wait. Be patient. Now, so we have to make sure and check it if the fx is satisfy three conditions. First, if the value of fa exists. So first we have to check whether value of fa, in this case, for our example, f1 is exists. But in our case, f1 is not exists because the result is 0 over 0. So we know that this is not continuous graph. So to check whether the graph is continuous or not, so we have to have the value of fa. Yeah, the value of fa should be exists. And then the limit function of fx is also exists. And the last one, we have to check that the value of the limit function and the value of fa will be equal. Yeah, so the value of the limit fx when x approaches to a is the same as value of fa. So we say that the graph is continuous. Yeah, because sometimes we have graph that the value of fa is axis, the limit is axis, but the value of the fa and the limit function are not the same. Yeah, because from the right side and from the left side, maybe the graph will be different. So this is not continuous graph. Yeah. Now, using this idea of limit function, now we try to see about differentiation. So let's say we have any random function fx. So when x equals to x1, I have fx1. And for the second point, for x equals to x2, so I will have y value as fx equals to fx2. So if I draw, this is the random function. So the 2 points P and Q representing x1 and x2. And we have a separation between x1 and x2 as a delta x in the picture, yeah. Now, the difference between the points, so we can subtract the fx2 minus fx1. Yeah, this is the difference between the points. And the delta x is the difference between the x values, yeah, x2 and x1. So now we can rewrite an expression for fx equals to x1. This is the same. And now for x2 is the x1 plus delta x. Yeah, because if you see from the graph before, between x1 and x2, there is a separation of delta x. So that means that means from here, we can say that delta x is x2 minus x1. So x2 is x1 plus delta x. So that means I will have fx2 as the fx1 plus delta x. Yeah, this is the same. Yeah, so I replace the x2 there into x1 plus delta x. Now, the difference between the points become fx1 plus delta x minus fx1. Yeah, so this is similar from the previous slides. Yeah, the previous slides we only say about. I moved back 2 months. Yeah, from here, the difference of the points is fx2 minus fx1. Since x2 now is x1 plus delta x, so the difference of the point now become fx1 plus delta x minus fx1. Yeah, you can see the delta y there. Yeah, delta fx is the delta y, the rise, while the delta x is the run. So, what is the differentiation? Differentiation, or we call it as a derivative of a function, measures the sensitivity to change of a quantity. This quantity usually a dependent variable, which is determined by another quantity of different independent variable. So if we want to see about the effect of the change of the quantity, in this case is delta x and delta y. So we use differentiation to see the relationship, to see the effect of the change of the quantity. Yeah, the delta y is the dependent quantity and the delta x is the independent quantity. Yeah, in this case, delta fx is the delta y. Yeah, the change of the quantity. Yeah, dependent quantity. Delta x is the independent quantity. Yeah, dependent variable and independent variable. So I can have f prime x. Yeah, f with the apostrophe there is the f prime x. So that's the differentiation of function f, or a derivative of a function f is equals to the change of fx over the change of x. So we can replace the value of delta fx there by using the previous expressions. So the derivative of fx, yeah, f prime x equals to fx plus delta x minus fx over delta x. Now, since delta x gets too small, yeah, we try to make the delta x approach to 0. So we have to put the limit function. Because if we don't put the limit function, the result will be undefined because it's 0 over 0. The delta fx is 0 and delta x is approach to 0. So there is no difference. But since we are looking for the undefined region, so now we have to use the definition of the limit function. So when we can see that the derivative or the differentiation of function fx, yeah, in this case it's f prime x, is a limit when delta x is approach to 0 of delta fx over delta x. Or we can just write fx plus delta x minus fx over delta x. So this is called as a first principle method of differentiation. So using this formula, this definition, we can do the differentiation to the equation of fx. And we will see more about the differentiation in the other video. I, you can check the differentiation video about the rules of differentiation, and then later on for the application of differentiation will be explained in the separated um, video. So please check that video, guys. So this is the end of the video. Thank you. Bye.